Hi everyone, hope all's going well. This is sketching a solution to a system of inequalities. So we've done systems of equations. Again, these are inequalities. So we're going to be doing some shading after we isolate y in both of these equations. So if you notice, they're marked here. So this top equation, x plus y less than -2, I'm just going to first step is put that into slope-intercept form, and I've got the little dot to indicate which equation I'm working with. So if I start with my x plus y less than -2, isolate y, I'm going to subtract x on both sides, bring everything down. Remember, subtracting doesn't flip the sign. Multiplying or dividing by a negative on both sides flips the sign. So I have y still less than, combining a negative x or a -1x with a -2. And now I've got that equation isolated. Let's do the same thing here for the bottom equation. So I'm going to start with 2x minus 3y is greater than -9. So first step, undo any addition or subtraction. So here we're subtracting a 3y from a 2x, and we want to isolate y. That's the goal. So we're going to get that 2x out of there by undoing it or subtracting. So when I do that, again, we're not flipping the sign because it's just subtraction. Bring everything down. -3y, sign stays the same. Combining a -2x and a -9. I cannot put those together because they're unlike terms. Now, when I divide both sides by -3, a couple of things to pay attention to here. Whenever I divide by the coefficient or the number in front of the variable, and there's a addition or subtraction operation on the other side, or several, if there were 5 different terms here, I would need to divide each term by whatever the coefficient is. So remember, if it's separated by a plus or minus, it gets divided by that coefficient. In this case, that coefficient's -3. So then, the second part to pay attention to, this turns into 1y. We did divide by a negative, so the sign does change directions. A -2 divided by a -3 is a positive 2/3. X. 9 divided by 3 is 3. And it's negative divided by negative makes it a positive 3. Okay, and so now I've got both inequalities ready for graphing. So let's start with the red graph. Remember, you're going to go to your y-intercept. In this case, it's -2. Draw my point at -2. And then I'm going to employ my slope, or make my slope triangle, which is -1, right? This is -1/1, or 1/-1, either way. So I'm going to go down 1 and over 1, down 1, over 1, down 1, over 1. And I'm going to see this slope triangle pattern. So I can just follow that pattern all the way across the graph, like that. Then I'm going to go ahead and graph that with my straight edge. Since this inequality does not include the line, it means the line is dotted, meaning it has a border, but it does not include the line as if it's not there. Kind of like you would draw a shape to show that a line exists, but you're not counting the line. So it ends up being a dotted line. Okay, so that is there and there. All right, and then we want to graph all values below that line on the y-axis. So below that on the y-axis. So here's a y-axis. We're going to go below it. So we're going to shade below that line. Then we're going to do the identical same exact process for the blue line, or the second equation, second inequality. I'm going to start again at my y-intercept, which is +3. And this time the slope is positive. So I'm going to go up 2, 1, 2, and then I'm going to rise 2, and then I'm going to run 1, 2, 3. Now I'm off the grid. It's always a good idea to fill the grid, so I'm going to go the other direction with my slope triangle. Down 1, 2, and back 1, 2, 3. And that way I have my inequality. Again, it is just an inequality, meaning it does not include the line. So again, it's another dotted line. Okay, so here's my dotted line that represents the second equation. And I'm going to graph all values of y below that. So below that line, so here's that line, everything below that line. And then the solution to the system is probably the trickiest part. It's finding the shaded area that exists in both situations. So if you can kind of see, this is both below the red line and below the blue line. Okay? And you could pick any point in there, any point of intersection. There, for example, right here, way over here in this quadrant. You pick any one of those points, and this one right here looks like it's -4 and -2. And if you were to plug those values into this equation, inequality, and this inequality, it would be true for both of them. And that's how you sketch a solution to a system of inequality. Isolate y in both equations, graph both lines, taking note on whether the line is dotted or solid. Solid means it includes, dotted means it excludes, and then you're shading the values above or below the line based on the y-axis.